Okay, for the first question, C4H10O, for the chain isomerism is different in carbon chain, but same functional group and belong to the same homologous series. This is the first isomers. C4H10O is alcohol, so we draw 4 carbon and we put the OH at the end of the first carbon. We fill the carbon with hydrogen. This is first chain isomers. From what we learned, chain isomers will only change the carbon chains, but not the functional group, which is OH. So that means OH will remain at the first carbon. So we draw 3 carbon and we put the CH3 at the second carbon. So for the IUPAC name for this chain isomers is 2-methyl-1-propanol.
So for the second structure isomerism, we have the positional isomerism. Positional isomerism means have same carbon skeleton and belong to the same homologous series but differ in the position of functional group. Just like what we learned, positional isomerism means we only change the position of functional group. So this is our first positional isomers. Firstly, we draw the 4 carbon and then we change the OH, which is the functional group, from the first carbon to the second carbon. The IUPAC name for this isomer is 2-butanol.
Third is functional group isomerism, which is have different functional groups and belong to different homologous series. The general formula for alcohol is CnH2n plus 2O. Since ether has the same general formula as alcohol, C4H10O can be formed as ether. For the isomers, we put the O in the middle of the 4 carbon chains. From this structure, we can determine the functional group, which is COC. For the IUPAC name is diethyl ether. Our second question is CH3, CH2, CH double bond CH2. The molecular formula is C4H8. We draw them as this. The IUPAC name for this is but1-ene. For the chain isomers, we draw 3 carbon and we put the double bond at the first carbon. Then we draw CH3 at the second carbon as branch. The IUPAC name for this chain isomers is 2-methylpropene. For the positional isomers, we change the functional group, which is double bond, from the first carbon to second carbon. And the IUPAC name for this positional isomers is but2-ene. Lastly, for the functional isomerism, the general formula for alkene is CnH2n. Since cycloalkene has the same general formula as alkene, C4H8 can be formed as cycloalkene. So we draw the structure isomers in cyclic, which each of C is connected to each other.
For the last question, we have CH3, CH2, 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 CH2OH, which in generally we called it as C5H12O. The structure of the isomer, we draw them as pentan-1-ol. First isomer, we can draw a branch of CH3 at the second carbon while the functional group, which is OH, remain at the first carbon just like in the question. And this isomer, we call them as 2-methylbutan-1-ol. Our second chain isomer, we draw them as 3-methylbutane-1-ol, which the branch of CH3 we change them at the third carbon. Our third chain isomer, we shorten the carbon chain become 3 carbon, and there would be 2 branch of CH2 at the upper and lower of second carbon. This structure isomer, we call them as 2-methylbutane-2-ol. Our fourth isomer, we already can draw the isomer as positional isomer, where the first positional isomer we call them as pentan-2-ol. This structure, we change the functional group of OH from the first carbon to second carbon, as the carbon chain remain as 4 carbon just like in the question. Our fifth isomer, just like the fourth one, we only change the functional group of OH from first carbon to third carbon, which we call them as pentan-3-ol. For last isomer, we can draw them as functional group isomerism. The general formula of C5H12O is CnH2n plus 2. Since ether has the same general formula as alcohol, C5H12O also can be formed as ether. For this structure of isomer, we draw O in the middle of carbon chain. We can see the functional group COC or alkoxy in the structure, which show the structure of homologous series is ether.